Hello, welcome to Have a Go, and I'm Alan. Trying something a bit different today, in that I'm going to cast the pulleys for the Leadscrew drivetrain, and I thought I'd start with how I created the patterns. Create new, start, part, then I go to part, create primitive. Cone is what I want, and create. Go to model. Incidentally, I'm using FreeCAD because I know that there are better free software, but they're owned by AutoCAD. And one, I don't want to create yet another user account with yet another password. 2, I don't want to use my Google Drive and give someone else access to my files. And 3, I don't like AutoCAD because of what they did to EagleCAD when they bought it. I bought a hobbyist license for EagleCAD, and after AutoCAD bought them, it's like, you know that license you bought? Pay us each month if you want to upgrade Eagle. Go on, keep paying us every month. So, stuff ya. I'm going to switch to something better with blackjack and hookers. FreeCAD suffers from the free software phenomenon where the interface is not designed by user experience experts, but by computer programmers who think that a wall of microcode is a good interface. But you learn to use it. Rant over. Right, so we'll start working on this. So there are basically 2 circles in this, but I want them to be cones, because I'm going to need draft angle in order to get them out of the sand mold. The bottom circle will be 100 mil diameter, and the top circle will be 25 mil diameter. So at the moment we're creating the bottom circle with radius of 100 mil. Zoom out and fix the other radius with a radius of 105. This is a laughable amount of draft on it, but I want to be able to get it out of the sand easily and without having to do any finishing on it. We'll change the height to 12 millimeters because I want to. Now to create the next part of it, go to part. Okay, try that again. Part, primitives. Why won't it let me? Okay, it worked the other day. This is what I mean. Things stop working and it's not obvious why. Okay, now we've got our other one. We'll change the placement because if you recall, the bottom one is 12 millimeters high. So we need to move it to 12 millimeters up so it's above that one. See, and there we have a little one just above it. Teeny weeny little one. I don't know what happened there. So once again move it to 12 millimeters up. So now it's sitting on top of it. And change it so that the bottom radius is 30. I'm adding 5 millimeters again for the draft, so the top one's okay. That's round the other way. FreeCAD was mooing for a bit, but it seems to have come right. And now we have our pattern with the bottom disc with draft on the side and our top disc with draft on the side. It's a lot more draft than I probably need, but I'm blowed if I know how to get FreeCAD to do 5-degree angles. and you've seen just how bad this thing is to work with. So we select both of them, and with both of them selected, otherwise it won't work properly. File, export, call it video for now, .stl, bring up Ultimaker, add video.stl, which we just made. And don't ask me why, but this doesn't get the sizes right. So if you recall, the diameter was 105, and it doesn't get the vertical scale right either. So disable uniform scaling and set that to 24. Go to slice, save the disk, and we take that to the 3D printer, hit it with a stick until it prints something. From here it prints, then we go to the shed with the pattern, and I'll see you out there. Right, this is the printed pattern. The result of our hard work on the computer and the 3D printer. Now I'm going to use this, ram it up and cast. I did 2 of them so I can cast them both at the same time. Rid of the excessive parting powder. Tip I got from Chirpy: if you're going to do multiple castings, put the pattern on top of the flask so you remember what the flask is for. Then before you go to cast, take it off. Right, I forgot to put a weight on top of this one, and so there was a blowout out the side. I'm hoping that it worked out despite that. Yes, I think I got away with it. They're wide and flat castings, so there would have been a lot of pressure pushing the cope up, which is why they would have had a blowout like that. So wait for these to cool down, zip off the gates, and then I can spin them up on the lathe and clean them up. Easy stuff first. Right, I'll just zip these off with the bandsaw. Right, let's call it 20. Right, just marking out where I'm going to drill the holes for this. Right, I'll just drill these out for 5 mils so I can tap them. Alright, let's try and centre this up a bit. What's going to be the best way of putting a V into that thing? I'm just about certain this is probably the wrong way of doing this. If someone knows a better way, let me know in the comments, because I am making this up as I go. Ugly, but it should work. Carriage is hitting the blasted thing. Well, I was trying to face off the surface, and it seems to have been forceful enough when it hits the steel screws that the thread on the insert, or the thread on the little bolt holding the insert in, seems to have stripped a bit, come very, very loose, which I'm very annoyed about. Going to drill a hole in this for the centre, or I should say for the bolt that will be the axle to go through. Lock the carriage, lock the tailstock down. I'm not drilling the entire way through because there's still the spindle nose on the other side and I don't want to hit it. And that's that ejected. Okay, I definitely lost concentricity there when the facing operation hit that screw head and got all boogered up, but for my purposes this shouldn't be turning fast enough for it to be a problem. There's extra space there, so I've got some nylon and steel washers I'm going to use for thrust bearings on it. Probably won't be turning fast enough to need a bearing in there. So maybe tidy it up a bit with the file, but otherwise that's that one done. I just have to turn up this one. I'm mounting these on the faceplate using a stack of 4 washers as spacers, which isn't ideal, but I don't have any better because I don't want to use one of my 1, 2, 3 blocks because I'll end up chewing into the block when I face down the edge of this rim. Otherwise I would use the 1, 2, 3 block. Going to get that a bit closer when I'm working on the lathe. Right, I've just put a smaller belt on the pulleys going from the motor to the counter shaft, so hopefully it'll run a bit better. to turn this centre part because this will be going here, so it'll be, the pulley will only be going on the big one. Cleaning the floor is the really annoying part. Alright, let's take this off. Alright, because this will be going on the lead screw, I think I'll drill it out to 8.5 and then tap it for M10. Back in a flash. Dave Gingery is bang on the money when he says don't cheap out when you buy your taps. You need a good set because you'll get a lot of use out of it, so it'll be a good investment rather than spending a lot on something you won't use. Because these things you do use a lot. I hadn't realised that I drilled the hole off soldering centre. Okay, this is annoying. I thought I had some stock cast to machine for the pulley for this, but I don't. Bother. Gingery actually says to drill this hole when you're still working on this headstock, yeah, as a casting. In retrospect, that's exactly what I should have done. Incredibly annoyingly, my camera died just before I started on these. So you saw me put this pulley on. I've also mounted this pulley as well, using some thrust or some nylon washers as thrust washers. It's not a heavy load, so it doesn't have a problem. And for the pulley on this one, I've got two shaft collars next to each other with a small gap acting as the seat for these belts to sit on. As for this green round belt, I got the idea from Yuri Tushman. Sorry, I don't know how to pronounce it. I took inspiration from him on how to join them. I used my blowtorch setup to heat up the metal there, hence the discoloration. And once the metal was good and hot, I grabbed both ends of this, pressed them against the metal to melt it slightly, and then raised them together to join the two ends. Imagine there's another bit of green belt on connecting to there. Now I don't know what I was doing wrong, but just melting the ends together didn't work properly. Yeah, they pulled apart. So I wound up using super glue to join them together. Weirdly, just cutting it and using super glue didn't work, but if I melted the ends together and then it pulled apart anyway, the super glue would then work. You also need a certain amount of tension in these belts or they'll just slip endlessly. Looks like I need to shorten this belt again. Not having any trouble with this belt, so I think I need to reduce the length of this one and increase the tension. But otherwise, the Leadscrew drivetrain is more or less working. So what does this mean? It means that when I'm cutting long stock on the lathe, I can connect these belts up set the carriage up, and it'll automatically feed along the length of it without me having to muck around with it. Thank you for watching and have a nice day.